Hey guys, so we're still on this new unit, Unit 9, talking about volume. So last week we talked about volume of a rectangular prism, right? A cube or a prism, rectangular prism, length times width times height. We also talked about volume of a cylinder, okay, which was pi r squared times your height. Today we're going to be focusing on sphere. Okay, so what is the formula for volume of a sphere? How do we calculate it? And a couple of other things. So again, so far, we've covered um, volume of a rectangular prism or a cube, length times width times height. We did already a cylinder. That was pi r squared times your height. Today we're going to be focusing, oops, excuse me, not on pyramids. That'll be on Thursday/Friday. We are going to be focusing today on spheres. So volume is equal to 4 over 3 pi r to the third power. Careful with that, cubed, r cubed. So one more time, what is volume? What is volume? Well, volume is the quantity of a three-dimensional space enclosed by a closed figure. Basically, it's the space inside. So if you take a look at these little beakers over here on the right, it's how much liquid can they hold? What's the space inside? What's the space inside of any one of these shapes? That's what we consider volume. That's what we want to make sure we talk about today. So again, just to recall, volume of a rectangular prism, guys, that is just length times width times height, right? The idea is that if you take your length times your width, that is just area, right? That's the area of a rectangle. So this would be a flat surface, a two-dimensional surface. Once you start multiplying it by its height, well, you start stacking a bunch of tiny thin pieces of paper, a bunch of rectangles on top of each other, almost like you're 3D printing. Eventually, you'll create this rectangular prism, which will give you your volume. Um, Same idea with volume of a cylinder. The formula for volume of a cylinder is right here, pi r squared times your height. And again, if you only did that first little section, pi r squared, that is the area of a circle, right? So you would just found out the area of a flat figure here of a circle. Once you start multiplying it by its height, well, that means kind of like you're starting to stack a bunch of circles on top of each other, right? A bunch of what's the chips? The Pringles, right? Stacking a bunch of Pringles on top of each other. Eventually, you'll fill up the top of that can, which we consider volume of a cylinder, right? That's an oversimplified explanation, but hopefully we get the idea. Stacking a bunch of circles on top of each other will create a cylinder, which is how we get volume. So what is the new one for today? Volume of a sphere. Um, the volume enclosed by a sphere is given by the following formula. This is the formula 4 over 3 pi r to the third power. And again, r is still, just like before, it's still going to represent radius. R is still the radius from the center. Remember, center of that sphere all the way out to one edge or the outside surface of that sphere. That is what we consider the radius. Please be careful not to confuse it with diameter. Diameter is the one that goes all the way across, right? And they'll use the letter D for diameter. Radius is only half of that. Okay, so your radius, that's the one that we want. So be careful. Radius is from the center to the outside. Okay, and again, the formula is 4 over 3 pi r cubed. 4 over 3 pi r cubed. So here we have a sphere. Find the volume of the sphere. So let me make sure I write the formula. Volume is equal to 4 over 3 pi r, and again, it is cubed. Feel free to go back and forth. I probably will do that today. 4 over 3 pi r cubed. All right, make sure you go back and forth. No need to memorize it. You guys can use your notes on a test, on your assignments. I do not expect you guys to memorize these formulas, right? We have them. We can go ahead and look back at them in our notes. So find the volume of the sphere and round your answer to the nearest tenth. So I wrote down the formula, right? So let's fill in. And the nice thing is all we really need to fill in the formula before we can start working it out is r, which is our radius. So I'm going to write volume is equal to 4 over 3 pi, and then let's talk about radius. Well, what is the radius? And it's like, well, they haven't given it to me over here. Well, the way that we can find radius, take a look. They said from the very top of the sphere to the very bottom, that measures, right? If I go from top to bottom, if I draw a line, that measures 12 centimeters. Unfortunately, that is not the radius. That is the diameter. So what is my radius going to be? It's only, okay, from the center to the outside. Really, we only want half of that height of that sphere. Only half from the center to the outside. Well, what's half of 12? That is going to be 6. 6 centimeters is our radius. All right, so be careful. They won't always write it horizontally. Sometimes it might be vertical. Any line that you take from the center of that sphere to the outside would be considered your radius. All of those would measure 6 centimeters. So let's go ahead and plug that in. Let's go ahead and plug in 6 to the third power. All right, now let's go through and actually multiply a couple of things out. So what I like to do first here at the very beginning, well, let me write 4 over 3. I'm not going to work with that yet. I'm also not going to work with pi just yet. Okay, I'm going to do 6 to the third power, 6 to the third power. So I'm going to need my calculator. I'm going to take out my phone real quick. Well, 6 to the third power, that means 6 times 6 times 6, which gives me 216. This gives me 216. All right, I'm going to keep multiplying. So volume is equal to, now I'm going to multiply pi times 216. So I'm going to leave 4 over 3 as it is. And again, pi, now I'm going to multiply that times 216. But instead of using pi, right, on our calculators, I'm going to be using 3.14. All right, so make sure you're using 3.14, not the actual key on your calculator, just so we can all be consistent. So I'm going to multiply 216 times, let me use my calculator, times 3.14, which is pi. And that gave me a total of 678.24. All right, I got one more thing that I have to do here, one more thing. And I'm going to actually do 2 steps in one. I like to do this at the very end, 2 steps in one. What I'm going to do is I'm going to multiply that 678.24. I'm going to multiply it quickly by 4 and then divide by 3. Okay, whenever you multiply by a fraction, something like 4 over 3, multiply by 4 and then immediately whatever you have in your answer, hit divide and then by 3. This is what I'm going to do next. So volume is equal to, so 2 steps in one here. 678.24 times 4 is equal to 2,712.96, but I'm going to quickly divide that by 3, and I get a volume of 904.32. So that is my volume, but they wanted us to round it. They wanted us to round it to the nearest tenth. So let's actually go ahead and finalize our answer. Volume of the sphere is nearest tenth would be the 3's place here. To the right, there's a 2, so it's going to stay as 904.3, and don't forget the units, centimeters cubed. This is 3-dimensional space that we're talking about. That is our final answer. Volume is equal to 904.3, rounded to the nearest tenth place. Okay, example number 2. A basketball has a diameter of 10 inches. What would the volume of the ball be? Round your answer to the nearest tenth. Okay, so I'm going to do my best this time. They don't give us a picture, but I'm going to do my best here. All right, here is my, whoa, go back. Here is my sphere as best as I can. Try to make it 3-dimensional. There's the front side. There's the back side with a dotted line. And again, they're telling us that the diameter, see if I can highlight that, is 10 inches. Now be careful, the diameter is from one edge all the way across. That is saying that that was 10. I don't need the diameter for volume of a sphere. Remember, volume of a sphere is equal to 4 over 3 pi r to the third power. All we need is r, which is our radius. So if our diameter, if the whole thing is 10 inches, what is just this little section here? It was just half of that, which is 5 inches. So that is what I'll be using for my radius. Be careful not to use 10. So let's fill in what we know. Volume is equal to 4 over 3 pi. And then r here, that's 5 to the third power. Let's go through and multiply that 5 to the third power. What does that mean? Volume, I'm going to show my work here every step of the way. Volume is equal to 4 over 3 pi, not multiplying by pi yet, but 5 to the third power. That means 5 times 5 times 5, which is 125. Okay, I'm going to multiply that 125 now times pi actually times 3.14. Remember, make sure you're using 3.14 for pi. We're going to multiply these two things together. So what is 125 times 3.14 on my calculator? That gave me 392.5. Okay, I have one last thing that I want to do here. The last thing that I'll be doing is multiplying by 4 and then immediately dividing by 3, right? We want to multiply by 4/3. So we multiply by the top and immediately divide by the denominator. So 392.5 multiplied by 4, that gives me 1,570. But I immediately divide that by 3, and I get volume is equal to 523.333, and it goes on forever, ever. So let's write our final answer here. What is it going to be? Let's write our final answer. Volume of this sphere, volume of this basketball, if I round it to the nearest 10th place, that's going to stay as 523.3. And this was in inches, so it's inches cubed. That is the volume of this basketball. All right, problem number 3. It says approximately how many times as great is the volume of a grapefruit? So right here we have a grapefruit with a diameter of 10 centimeters as the volume of a lime with a diameter of 5 centimeters. So now we have two problems and we have to basically compare them. How much bigger is that grapefruit? So how much bigger is that grapefruit? So we have two problems really in one, and we're going to try to figure out how much bigger. Oh, there we go. So let's go ahead. I'm going to try to break up my screen here. I'm going to try to break it up. On the left, we'll calculate the volume of the, let's say, grapefruit first, since that's the first one that popped up right in the story. I'll say grapefruit here. Okay. So my volume for my grapefruit, volume is equal to, since it's a sphere, right? We have a sphere. If you want to, it's not the most accurate sphere, but it's a sphere nonetheless. Volume of a sphere is 4/3 pi r to the third power. So again, let's fill in that r. What is that r going to be there? That r, the radius, well, they give me the diameter. The diameter is 10 centimeters. But again, the diameter is all the way across. I need the radius. The radius is only halfway through that, which is 5 centimeters. So we're going to say volume of this grapefruit is 4/3 pi, and then 5 to the third power, 5 centimeters to the third power. Well, let's go through and actually multiply this out. Volume is equal to 4/3 pi, and then 5 to the third power. What's 5 times 5 times 5? That's 125. Okay, I'm going to multiply that by 3.14. I get 392.5. Volume is equal to 4/3, and then 392.5, and then I'm going to multiply it by 4 and immediately divide by 3 to get the final volume of this grapefruit. So times 4 divided by 3, I get 523.333, and it goes on for a while, so I'll stop right there. So that is the volume of the grapefruit. Now let's see what is the volume of this lime. All right, and again, the volume for a lime, let's imagine this was a perfect sphere. Volume is equal to, again, 4/3 pi r to the third power. Well, let's go ahead and replace that r. Let's go through and replace that r, okay, with the radius. Well, it says the diameter is 5. So again, they give us the diameter all the way across this line. It measures 5 centimeters. So what's just half of 5? That's going to be 2.5. Okay, centimeters. So again, the radius for this one's going to be 2.5. So we're going to say 2.5 for r, 0.5, not 25, 2.5, whoa, to the third power. Okay, well, what is 2.5? Let's actually start to work this out. What is 2.5 to the third power? 2.5 times 2.5 times 2.5. That gives me 15.625. So volume is equal to 4 over 3 pi times 15.625. Let's multiply that by pi. Let's multiply that by 3.14. So what do we get? What is 15.625 times pi? 3.14. I ended up with 49.0625. And you don't want to clear your calculator just yet, right? You don't want to clear it. You don't want to round it just yet until the very, very end. As soon as you start rounding, before you get to your final answer, you will get round off error. So we like to save as many of these digits as we can. You don't want to just cut it off. So let's find the final volume of this line by multiplying 49.0625 by 4 and then immediately dividing by 3. So times 4 equals 196.25 divided by 3. That gives me 65.416. I'll round it to 0.42. And again, that is the volume of the line. Now, have I answered the question? No, not yet, right? The question was, let's see if I can find a different color. How many times as great? So how many times bigger is this grapefruit? Look at that grapefruit, right? It has a volume of 523.33 centimeters, and the lime only has a volume of 65.42. So how do we find out how many times greater? All we have to do is divide those. All right, all we have to do is divide those. We're going to divide the grapefruit. Okay, see if I can break this up even more. Grapefruit divided by the lime. That will tell me how many times bigger that it's going to be. So what is that? What is 523.33 divided by 65.42? That gives me 7.995, and it goes on for a while, so we can actually round that to 8. It's almost 8 times its size. 8 times its size. Okay, so that'll be our final answer. How many times as great? Approximately 8 times as big. So that grapefruit is 8 times as big as that lime, approximately. So example number 4, it says Margaret is thirsty after a 5 kilometer run, 5 kilometer run for charity. The organizers offer the containers of water shown in the figure. So she ran a 5K for charity, and obviously she is exhausted. They have containers of water, which they show here. One of them is a sphere. One of them is a cylinder. Margaret wants the one with the greater volume of water. Obviously, I would too, right? I would too. If I just ran a 5K, I'm exhausted, I'm thirsty, I'm going to want a lot of water. I would want the container that holds the most, right? Which one has the bigger volume? Tell which container Margaret should pick. So what we have to do is we have to go through, find the volume of both of these, and compare it, right? Obviously, the one with the bigger volume is the one we're going to recommend. So let me put sphere, and then over here I'll put cylinder. And let's work this out. Let's see which container is actually bigger. Which of these containers are they ripping us off with one over the other, right? So for the sphere, remember, volume is equal to 4 over 3 pi r to the third power. Well, let's fill in everything that we know. Volume is equal to 4 over 3 pi, and then our radius is actually right here. They actually give it to us, it's 2 inches. So we're going to write 2 to the third power. And let's just go through and multiply as much as we can. Volume is equal to, what I'm going to do here is I'm actually going to do a couple of things in one step. Hopefully you guys are familiar with it. So I'm going to do 2 to the third power, and then I'm going to multiply that by pi. So 2 to the third power, that means 2 times 2 times 2. So far, just by doing this part, I got 8. And I'm going to multiply now times pi. So I'm going to multiply 8 times 3.14. That gave me, I'm going to show my work actually up to this point, 4 over 3 still, times 25.12. So all I did was 2 to the third power, 2 times 2 times 2, and then I multiplied that by 3.14. All right, I got one more thing I have to do here before I know the volume of this sphere. Multiply by 4 and divide by 3. Multiply by that 4 over 3 times 4, divide by 3. I ended up with a volume of 33.49, and I'll leave it as inches cubed. So that is the volume of the sphere. Let's see what the volume of the cylinder is going to be. What's the formula for volume of a cylinder? Well, it is pi r squared times its height. So let's fill in everything. Whoa. Let's fill in everything that we know. Let's fill in everything that we know. Volume is equal to pi. Well, what's the radius? It's also 2 inches. 2 to the second power. And then times our height. Well, our height of that cylinder is also another 2 inches. Okay. So let's go through and work this out. What I'm going to do first is actually pi is going to stay the same. And I'm going to do these 3 things together. I'm going to do 2 to the second power, which means 2 times 2. I ended up with 4, and I'm going to multiply it by that height, which is another 2, which gives me a total of 8. So I have volume is equal to pi times 8, or 8 pi. If I multiply 8 times 3.14, 8 times 3.14, whoops, 8 times 3.14, that gave me a total volume of 25.12. And again, this is in inches, so it's inches cubed. That is the volume of the cylinder. So which one would you recommend? Which one would I take myself? I would recommend the sphere. Okay. Pick this one. Okay, or we can just say sphere. Okay, the sphere wins. That one has a lot more volume. I'd rather have that one and not get ripped off the extra water, right? I just ran a 5K. I'm really, really exhausted.